Hey y'all, today we're going to talk about exponent rules. Now, before we begin, let's go over what an exponent is. It is always the small number that is to the top right of a base. So your large number is your base, and then your little baby number is your exponent. So 7 to the third would be 7 times 7 times 7. And when you plug that into your calculator, you can use the exponent button, or you can just type in 7 times 7 times 7. The answer is 343. Now, that looks a lot different than if you were to say 7 times 3 is 21. That's why you need to break it down. 7 times 7 times 7. Now, you all should know that at this point. Let's go ahead and go over some actual rules of exponents. So the first rule we're going to talk about is the product rule. Now, what does the word product mean? Product is the answer to a multiplication problem. But you're not going to be multiplying here. The product rule, you use this rule anytime you have an exponent problem that has a multiplication sign there. So we have 3 to the second times 3 to the third. Anytime you have a multiplication symbol, you have a product rule. Now, what's important to remember about this rule is if the base is the same, which in this case it is a 3 and a 3. If the bases are the same, you're going to add the exponents. You're going to add the exponents. So, looking at this, if the bases are the same, are these the same? Yes, they're both a 3. Because it has that multiplication symbol, it tells you the product rule, add the exponents. Do not multiply them, add them. So 3 to the second times 3 to the third, bases are the same. So you keep your base of 3, keep that same base, add the exponents. 2 plus 3 is 5. So 3 to the fifth is your answer. You can go ahead and break this on down and have 3 times 3 times 3 times 3 times 3. And in your calculator, when you plug that in, 3 to the fifth power, you'll get 243 as your answer. But typically, when you have an exponent problem, they're wanting just that simplified exponent answer. So 3 to the fifth would be your answer here. However, on select all that apply problems, this is also correct and this is also correct. So let's look at our second problem. 4 times 4 to the 8th. Before you jump to conclusions and say 4 to the 8th, you need to make sure you always remember anytime there is not an exponent visible, the exponent is an imaginary 1. So this changes the answer. I have 4 to the first times 4 to the 8th. That times tells me remember my product rule hint. Are my bases the same? Yes, they both are base of 4. Because they're both the same, I'm going to add the exponents. So keep your base, 4, add your exponents. 1 plus 8 is 9. So my answer, 4 to the 9th. All right, let's try something that the bases are not the same. My rule for product, this has a multiplication sign, product rule. If the bases are the same, you add the exponents. Okay, let's go ahead and write that up there in case you're unsure of that plus sign, or maybe you jumped on here too late to listen. Are the bases the same? No. This is a base of 2. This is a base of 3. The only time you're allowed to add the exponents is if the bases are the same. Because the bases are different, you have to actually work this problem out. So in your calculator, you're going to say 2 to the third power, and that would be 2 times 2 times 2, which is 8, times 3 to the fourth power. So 3 times 3 times 3 times 3, and 3 to the fourth power is 81. So 8 times 81 is what you could write as your answer, or you could actually solve this all the way out 8 times 81, and you know that your answer is 648. So the difference in the top two problems, those bases were the same, so you were able to just add the exponents. This problem, the base was not the same, so you cannot add the exponents. You have to actually work each individual exponent problem out, then multiply your answer at the end. Okay, let's move on to the quotient rule. What does the word quotient mean? Quotient means the answer to a division problem. Okay, so we learned about the product rule, multiplication problem. We add the exponents. All right, so what is just the opposite of multiplication is division. Well, what's the opposite of addition? Subtraction. So if the base is the same, what do you think we're going to be doing for quotient? We are going to subtract the exponents. All right? Make sure you have those notes written down. If the base is the same, we're going to subtract the exponents. So let's look. I have 4 to the third divided by 4 to the first. So 4 to the third over 4 to the first. Are the bases the same? Yes, they're both a base of 4. So let's keep that base. Now let's subtract the exponents. 3 minus 1 is 2. So my answer is 4 to the second power. And like I said earlier, you can go ahead and break this all the way down and show the different types of answers. So 4 to the second would be 4 times 4, which would also be 16. All right, let's go ahead and look at the next problem. What do you notice? The bases are not the same. Just like on our product rule, when the base is not the same, you have to work each individual piece out. So 3 to the fifth, that would be 3 times 3 times 3 times 3 times 3. In your calculator, 3 to the fifth power is 243. Divided by, this would be 2 times 2 times 2. And if you input this in your calculator, 2 to the third power is 8. So now you can actually divide 243 divided by 8, and you get 30.375 as your answer. You can also leave this as your answer, 243 divided by 8. Does this simplify down? If you're looking for a division type answer, 243 over 8, you can put that. However, sometimes this will appear as your answer, the full problem. Let's look lastly on this particular video, let's look at the zero exponent rule. Now, anytime you have 0 as your exponent, the zero exponent rule always equals a 1. All right, what do you mean always equals a 1? Anytime you have 0 as an exponent, your entire problem changes to a 1 for that section of the problem. So 3 to the 0 power, 1. 2 to the 0 power, 1. This is the easy rule. 7 to the 0 power, 1. 0 to the nothing power, don't forget, anytime there's not something present, it takes an imaginary 1. So 7 to the first power is 7. That's the difference here versus all of these being a 1. They actually had a 0 as their exponent versus this did not have anything. When it does not have anything, it's automatically a 1. So you need to make sure you remember the 1 versus the 0 exponent rule. I hope this helps you. Y'all have a great day.